Hello students, welcome back to my channel. Today I will be discussing again chapter number 10, Haloalkanes and Haloarenes. We have already covered preparation of haloalkanes. In this video I will be discussing preparation of haloarenes. Okay. Now we will be doing three methods for this. First is written by direct halogenation on benzene. Second is from toluene, and third is Sandmeyer's reaction. So for the preparation of haloarenes, there are three methods and we will be discussing them one by one. So let's move on to our first method. See, before discussing the first method, if you remember what we have done in case of haloalkanes, we have done the preparation from the corresponding alcohol. Now if we require to prepare haloarenes, it means we should try it with phenol as well. Okay, so it was in the case with haloalkanes, we substituted the OH group and introduced the Cl group. Now according to that, we can do the same thing if we take phenol and then substitute this OH group with Cl using PCl5. If you remember, we have used a variety of reagents like PCl5, PCl3, SOCl2, etc. So same can be done with phenol and we can produce chlorobenzene, but as you have seen, it is written poor yield. It means the reaction does not take place or the yield is very low. Now first of all, I will discuss what is the reason behind it. Okay. Now what I have told you that phenol cannot be used to prepare haloarenes. Phenol cannot be used to prepare haloarenes. Now what is the reason behind it? The reason behind is that the carbon oxygen bond in phenol has partial double bond character. Okay, now if I draw the structure of phenol, then you know that phenol is benzene ring with the OH group. Now this phenol, now if you see this phenol, you will see that this carbon atom has a double bond in it. It means this carbon atom is sp2 hybridized, and you know that sp2 and sp3 carbon atoms, for sp2 and sp3 carbon atoms, this is the series for electronegativity. Which is related to S character. More the S character will be there, more will be electronegativity. More S character, more will be electronegativity. It is proportional to S character is proportional to the electronegativity. Okay. Now if you see this sp2 hybridized carbon atom, okay, which is present in phenol, it has more tendency to attract electron towards itself. This carbon atom has a tendency to attract electron towards itself. So if you see, oxygen will have lone pair of electrons which will be attracted by this carbon atom. Okay, see. Now what will happen? The electron enter in conjugation with the ring. Now, if you see, when these electrons enter into ring, then there will be double bond here. Okay, this will carry a positive charge and here it will come a negative charge. It will form a resonating structure. Okay, now again you can draw the next structure in which there will be shifting of electron, and you can draw the next structure as well. When you draw all these resonating structures, you will see that this oxygen and carbon will have a partial double bond character. Okay, this partial double bond character is going to develop over oxygen, so they will form resonating structures. And you know, since double bond is stronger than single bond, so it will be difficult to break this bond and substitute OH from Cl. So what you will write, the question can come, why phenol cannot be used for preparation of haloarenes? So what is the main reason? You will write down, because carbon oxygen bond in phenol has a partial double bond character. This will be the your main reason, partial double bond character. Okay. And why this is so? You can explain this, that carbon is sp2 hybridized. What you will write? Carbon is sp2 hybridized and attract the lone pair of electron towards itself. So the electron of oxygen enter in conjugation with ring and develop partial double bond character. And you can even draw all the resonating structures, so the concept will be clear to you. Okay, so this was the reason why we don't use that reaction. Now let's come on to our main topic, the first method. The first method for the preparation of haloarenes, which is by direct halogenation of arenes. What does arene means? Benzene. So the first method is by direct halogenation of benzene. This method is not given in your NCERT book, but you have studied this in class 11th. See, halogenation of arenes in the presence of Lewis acids like aluminium halides or ferric halides, which act as catalysts, produce haloarenes. So the reaction is written benzene plus Cl2. See, the catalyst is also written Fe or FeCl3. What is important? You need to write dark here. The reaction takes place in dark, because in the presence of sunlight or UV light, the reaction will be different. I will discuss that also. So for this, you will show benzene plus Cl2 and then the catalyst, and then you will write down dark. Then we will get chlorobenzene. Same we can do with Br2 also. Benzene plus Br2, what will be formed? Bromobenzene will be formed. Okay. Now what is the role of FeCl3 here or AlCl3 here? It acts as a Lewis acid. Okay. This will act as a Lewis acid, and it will produce electrophile, which is Cl plus. Okay. Now if you need to see how it is possible, then see what will happen actually. The Cl2 we have taken, and suppose if we use AlCl3, then these will react to form AlCl4 minus plus Cl plus. This Cl plus will get attached to the benzene ring. Okay, this Cl plus will attach to the benzene ring, and the hydrogen will leave the ring by donating its electron, so that double bond will be restored. So what will be the final result? That hydrogen of the benzene ring will be replaced by Cl. Fine. Now one more thing that I told you, that this reaction takes place in dark. You need to remember this. Now if suppose there is presence of sunlight, okay, now if there is presence of sunlight, then the reaction will be different. That I will discuss further. Okay, now I hope this one is clear to you. What has happened? We have done by direct halogenation of arenes. What we have done? By direct halogenation of benzene, we have produced chlorobenzene and bromobenzene. Okay. Now see further. Iodination can also be done. But what you need to remember is that direct iodination of arenes is reversible. So it is carried out in the presence of oxidizing agents like HNO3 or iodic acid, which oxidizes Hi form to I2. Okay, you need to remember this. See, we have already done chlorination and bromination. For iodination, we require some oxidizing agents. Okay, but fluorination cannot be carried out because the reaction is very violent. Okay, fluorination cannot be carried out. Now see further. So we have covered our first method, which is by direct halogenation of benzene ring. Now this is our second method. Okay. As I have told you, the first method is not there in NCERT, but this method from Toluene is there, and it is under the heading by electrophilic substitution. Okay. According to your NCERT book, this reaction is under the topic by electrophilic substitution. Now let us see this in detail. What will happen in this? See, aryl chlorides and bromides. Aryl chlorides and bromides can be easily prepared by electrophilic substitution of arenes with chlorine or bromine. See, again you need to remember, we are doing chlorination or bromination in the presence of Lewis acid. Okay. Now here what we have taken? We have taken toluene. Benzene ring with CH3 is known as toluene. We react toluene with chlorine or bromine. Then we get the corresponding ortho and para products. Now why this is happening? Why there is generation of ortho and para products? See students, as already the benzene ring has CH3 group. Okay, now this you have studied in your 11th standard, that if there is already mono substitution on the benzene ring, like here the mono substitution is CH3. Now the further substitution will take place at which position? It will be decided by CH3. You need to remember that CH3 is electron donating group. Okay. You need to remember CH3 is electron donating group, and it will activate the ortho and para positions. So ortho and para position will have higher electron density in comparison to other places. Okay. So what will happen? If we take toluene, then we will get ortho and para products. Okay. So if you see the reaction, you will see here that what is happening? If we take toluene, then we will get ortho halotoluene and para halotoluene. If I take Cl, I will get ortho chlorotoluene and para chlorotoluene. Now the ortho and para isomers can be easily separated due to large difference in their melting points. Okay, this can come in exam as well, you need to remember this. Now one more thing, if we talk about major and minor, then in this case para will be a major product. You need to write down this also, that para will be a major product. Now why this is so? If you see both the structures, then you will see that in this both the groups are adjacent to each other, so there is steric hindrance. But here there is no steric hindrance, so this is a major product. Fine. Now again, what we have done? We have done either chlorination or bromination, and for iodination, what we need? The presence of an oxidizing agent, and for fluorination, fluoro compounds are not prepared by this method due to high reactivity of fluorine, and the reaction is very violent. Fine. So I hope this second method is also clear to you. Now let's move on to our next method. Okay. Now we will see preparation of haloarenes from disonium salts. Now what are these disonium salts? See, you have a separate chapter for this. So we will have just an intro of this. Now see, benzene disonium chloride is highly unstable. This compound, benzene ring with N2Cl on it, is known as benzene disonium chloride, and it is a unstable compound. So it is prepared in situ by reacting aromatic amines with HNO2. Okay. So this reaction first of all is known as diazotization. This you will study in your further chapters, diazotization. What we are doing? First, we are preparing benzene disonium chloride by the reaction known as diazotization. For this, we will take aniline. Okay. Benzene ring with NH2 attached is known as aniline. Aniline will react with HNO2 and HCl, and temperature will be 273 to 278 Kelvin, or you can write 0 to 5 degrees Celsius, and we will get benzene disonium chloride. Now the further reaction we will do on this benzene disonium chloride. This reaction is known as Sandmeyer's reaction. Okay, very important name reaction, Sandmeyer's reaction. Now what we have done? We have prepared benzene disonium chloride. Now by treating benzene disonium salts with CuCl dissolved in HCl, chlorobenzene is formed. Okay, so what we have done? We have used aniline first and converted it into BDC, benzene disonium chloride. Okay, then the reagents we use is CuCl dissolved in HCl. Then we will get our desired product, which is chlorobenzene, with the generation of N2 gas and CuCl. Okay, similarly, if we use Br, we can do bromination. So again, what is this? BDC, benzene disonium chloride, and if we take CuBr in HBr as catalyst, what we will get? Bromobenzene. So this is the third method of preparation of chlorobenzene and bromobenzene. Now if you move on further, see students, if we need to prepare iodobenzene, see, if we need to prepare iodobenzene, so treating the disonium salt with aqueous Ki solution and by just warming it, we don't need any other catalyst for this, okay, because I minus is the best nucleophile, okay, so we don't need any of the catalyst in this. So I minus is itself capable of carrying out the reaction, and then we will get iodobenzene. So again I am repeating, for Sandmeyer reaction we have discussed first chlorination, bromination and iodination. Now what is left? Fluorination. Now as we have seen earlier also, that the reaction is very violent, but there is a specific reaction which is known as Ball-Schiemann reaction. See students, this is not given in your NCERT, but you need to know about this reaction. This is known as Ball-Schiemann reaction. By heating the disonium tetrafluoroborates, fluoroarenes are obtained. So in order to obtain fluorobenzene, this specific reaction is used. Okay. First of all, in this we do diazotization and we prepare benzene disonium tetrafluoroborate, and then further we react and get fluorobenzene. This reaction is known as Ball-Schiemann reaction. Okay. I hope all the reactions are clear to you. See, again I am telling you that we have discussed mainly three methods of preparation of haloarenes. Okay. Today I have discussed mainly three methods. First one is by direct halogenation on benzene. Okay. We have seen chlorination and bromination in this, and then from toluene we have again seen chlorination and bromination, and we have prepared ortho and para products in this, and then we have seen Sandmeyer reaction for chlorination, bromination and iodination, and for fluorine, for preparing fluoroarene, what we have seen? Ball-Schiemann reaction. So this was in continuation with preparation of haloalkanes and haloarenes. See, haloalkanes I have discussed earlier. In this video I have discussed haloarenes. Okay. Now this preparation part is over. Okay. Now next I will discuss with you the properties. So that's all for today. I hope it is clear to you. Thank you.